Our 6-12 lesson plan will utilize basic algebra to guide 9th to 10th grade students to find a relationship and patterns in a given problem. In class, we would draw a picture of a carton on the board and guide the students in discussing any patterns that they see in regard to the milk carton and any patterns they see as you increase the number of bottles or dividers per carton. After class discussion and sample problems in class, the following problem will be given as homework. Matheson has a problem. He works with a company that uses square bottom milk crates. These can be divided up to contain a square number of bottles fitting the crates with dividers. Using 2 dividers, Matheson can fit 4 bottles into a crate. Using 4 dividers, he can fit 9 bottles in another crate. On Friday, Matheson's boss wants to know how many bottles can fit into a square crate if 30 dividers are used. On Tuesday, Matheson's boss wants to know how many dividers would be needed for a square crate that could hold 100 milk. In the diagram shown, we can see that half of the number of dividers are on each side of the crate. For example, if you have 2 dividers going in a milk crate, 1 divider goes widthway and 1 lengthway. For 4 dividers, 2 go widthway and 2 go lengthway. We can also see that the number of bottles that will fit on the sides of the crates are 1 more than the number of dividers. For example, 2 dividers will create space for 3 bottles, and 1 divider will make space for 2 bottles. By drawing this diagram, we would reiterate the fact that half of the dividers are used lengthways and half widthways. So 2 dividers, 1 will be used lengthways, 1 will be used widthways. For 4 dividers, 2 will be used lengthways and 2 widthways. Using the patterns described, we will go over the first half of the homework problem, which states, on Friday, Matheson's boss wants to know how many bottles can fit into a square if 30 dividers are used. We also know that the number of bottles that will fit on the sides of the crate is 1 more than the number of dividers. So 15 dividers plus 1 will give a total of 16 bottles on each side. The milk crate is a square, so you take the number of bottles on each side and square it to find the total number of bottles that will fit in the crate. 16 times 16 is 256, so 256 bottles will fit into a crate using 30 dividers. At this point, we would show our students this table, which shows a couple unique patterns in both the number of dividers and number of milk bottles in given crate numbers. On the left-hand side, we see that the number of dividers is a steady increase of 2 each time. On the right-hand side, we can see that the number of milk bottles that will fit in the crate is a steady increase of a 1x squared. So in a crate with 2 dividers, you get 4 milk bottles, which is 2 squared. And in a crate with 4 dividers, you have 9 bottles, which is 3 squared. This pattern is continuous. At this point, we would introduce the second half of the homework problem, which states, on Tuesday, Matheson's boss wants to know how many dividers would be needed for a square crate that could hold 100 milk bottles. 100 is a perfect square, and we know that 10 times 10 equals 100, so 10 milk bottles will fit on the sides of the milk crate. As we know, to find the number of dividers in a milk crate, it's 1 less than the number of bottles that will fit on the sides of the crate. Since 10 bottles are fitting on the sides of this crate, 10 minus 1 equals 9. That means that 9 dividers will be used on each side. Since 9 dividers will be used on each side of the crate, we know that 18 dividers will be used in total because 9 times 2 is 18. At this point, we have used the patterns we've discovered to answer both sections of the homework problem. Section 1 answers is 256 bottles will fit in a crate with 30 dividers. Section 2 is 18 dividers will be used in a crate that holds 100 milk bottles. The overall goal of this lesson was to use basic algebra and number patterns to discover patterns between the two in a given homework problem.